In today's video, we're going to look at section 8-1, monomials and factoring. So we're going to go back to the idea of being able to break apart a number. So as we look, we need to know what a prime number and a composite number. A whole number greater than 1 for which only the factors are 1 in itself is called a prime. So the first 8 would be 2, 3, 5, 7, 11, 13, 17, and 19. We can go on, but those we don't really need to memorize. A whole number greater than 1 that has more than 2 factors is called a composite number. So 4, 6, 8, 9, 10, 12, 14, 15, and those are all composite numbers. So we're going to talk about prime factorization, and this can be broken down for variables also. But first we're going to look at numbers. So by prime factorization, we can break up 90 into all prime numbers. Okay, multiplication of all prime numbers. So 2 times 45. And then 45 can be broken into 3 times 15. And then 15 can be broken into 3 times 5. So we end up with 2 times 3 times 3 times 5. So that's what we're going to be looking at doing in today's lesson. But when we talk about monomials, we're also going to be adding in variables. So factor negative 12a squared b cubed completely. So let's break up each one in each part of this individually. So I'm going to look at negative 12a and then the b. Okay, so we're going to look at all of these separately. So for negative 12, we could break it negative 1 times 12, and then 12 times 3 times 4, and then 4 could be rewritten as 2 times 2. So we have negative 1 times 3 times 2 times 2. And we're going to put all this together in order to make it more appealing. So then we're going to look at a squared. A squared really just means a times a. So it can be broken into a times a. And then the b can be rewritten, the b cubed can be broken into b times b times b. So notice when it comes to variables, the exponent tells us how many times it appears. So now our final prime factorization would be negative 1 times 2 times 2 times 3 times a times a times b times b times b. And there is our prime factorization, or our completely factored monomial. And that's what we're going to be looking at using in this section and for the rest of the chapter. So what we want to talk about is the greatest common factor. The greatest common factor of 2 or more monomials is the product of their common factors when each monomial is written in factored form. If 2 or more integers or monomials have a GFC of 1, then the integers or monomials are said to be relatively prime, meaning they don't really have a whole lot in common. So for practice, find the greatest common factor of 15 and 16. So 15 can be broken into 3 times 5. And then we look at 16 can be broken into 4 times 4, which can be rewritten as 2 times 2 times 2 times 2. So as we analyze these, we have 3 times 5, and then we have 2 times 2 times 2 times 2. Now, in that situation, they have nothing in common, so their GCF, I do that all the time, is actually equal to 1. So these two are relatively prime because they don't have anything in common. All right, but now we're going to take that a step further, and we're going to look at two different types, two different monomials. So we have 17d cubed and 5d squared. So 17d cubed and 5d squared. So 17d cubed, well, 17 is prime, so it's just left as 17, and then d cubed really means d times d times d. And then green, 5d squared, well, 5 is prime, so I'm going to leave it, and then we have d times d. So now we're going to circle everything that's in common. So we have 1d and 2d's. So we only have d times d, which is really d squared. So our greatest common factor is d squared. All right, let's do another one. So once again, let's see, we're going to do blue this time. Blue and orange. Okay, so 22 p squared q squared. So 22 can be broken into 2 times 11, and then p squared is just p times p, and then q, it's not q squared, I don't know where I got that from. Q is just times q. All right, so now let's do 32pr squared t. So we have 32 p keep doing that, r squared t. So this 32 can be rewritten. Now let's do a little scratch work. 32, let's see, we have 2 times 16, 2 times 8, 2 times 4, and then 2 times 2. Okay, I'm just showing that a way to do it. So it's 2 times 2 times 2 times 2 times 2. So we have 2 times 2, 2 times 2 times 2. Then we end up with p times r times t. Okay, so now I'm going to use underlining to help us show what we have the same. So we have 1, 2 the same. We have a p that is the same, and that's it. There's nothing else that they have in common. So we just end up with a greatest common factor of 2p. So there's not much that they actually share, which isn't a big deal. Sometimes they share a lot, sometimes they don't. So that is how we find the greatest common factor of 2 monomials. And sometimes you'll have to apply it to 3 or 4 or 5.